automation at PayPal. Beyond technology, he enjoyed traveling with his family, spending time with his daughter, and occasionally expressing his thoughts through poetry. So thank you, and please welcome Mr. Ankit for his wonderful topic from CVE to context, AI-powered enterprise software supply chain risk intelligence.
Hello everyone, I was prepared for a good morning, but it's afternoon already. So, good afternoon everyone, and thanks for joining me. And thanks to all the organizing committee and the AISEC community. It's an exciting era that we are living in, an exciting era of AI, where we are shipping faster than we can secure. Let me start with a question for all of you. How many of you have shipped code this week which included open source packages that you have not read a single line of? A lot of people. So you can keep your hands up if those packages pulled in other packages which you did not choose, and those packages put other packages also which you never wanted and never heard of. That's pretty much the topic that we'll be discussing and talking about in the next 40 minutes. We are sitting on a mountain of code that we are shipping, but we are not fully aware of, and that's the challenge. So today I'll be talking about how we can stop fearing that mountain and how we can start utilizing that. So from CVEs to context, it's not a product pitch. It's basically a way of thinking how software supply chain security, how basically we apply certain concepts to software supply chain security that changes what's possible. But now this is a threat landscape of 2026, how it looks like. So over here you can see, like in March there are around 13 exploits or supply chain scandals happened, which has increased to 41 in October. The new malicious open source packages have increased a lot. You can see the numbers over there. That's a very big number. We are shipping around 40 to 60% of AI generated code with a security flaw, and yet 12% of the teams are still review like everyone would. There are 581 open source vulnerabilities per code base, which are up 10% in the single year. That's a pretty significant number over here. And the cost of supply chain attacks estimated over next couple of years is around 60 billion to 138 billion. Now I just want to do a gut check with all of you. A question for all of you. How many of you feel that our security scanning and patching is keeping pace with the speed which we are shipping? Okay, that's the challenge that everyone faces currently, because we are all living in silos and we do not have an understanding. There are multiple scanners. First, we move to the second tab. Yeah, this one. So we are pretty much living in silos. We have multiple scanners. We have SAS, SCA, there are CVE fields, there's cloud registry. We are living in a world with too many signals, but they do not correlate. They do not talk to each other. And that's where when you see this number 4 million raw CVE findings, they are scattered across 5 different silos. Harsh, can you please click on the, yeah. So what happens when you unify? When you basically break the silos and when you connect the silos to unify it into a single graph. That's where you start getting signals of what you need to prioritize. Now from 4 million CVE findings, what you see over here is 2,690 critical prioritized findings that the CISO or leadership would actually want to act upon. So that's where the problem that we have currently. There's too much of noise, but we do not have much signals. But when you break the silos and get into a single graph, you basically achieve a orchestrated, like a prioritized list of what you need to act upon. Harsh. Slide. Next slide. How the landscape is evolving, the exposure window. Now, by the time we notice and see, we are already behind. So you can see a couple of numbers over here, which are like the median time from exposure to working exploit. It's reducing. It was less than 5 days. Now it is pretty much in negative. So the attackers can already exploit, or they are already exploiting before even we know about the public disclosure. For average CVE, for basically the analysis for the CVE to score it, it takes around 6 weeks. And the last year we only got around 28% of the CVEs average. That's a big risk. So what you're believing that's critical or high could also be critical. Average time taken by the enterprise to fix critical vulnerability is 137 days. That's quite a lot. And it's basically, let's say an example, you have a digital door in your lock in your home, and a burglar has a bug, he's identified a bug, so the burglar is coming to your home, stealing things, going away without you even noticing. And unless, because the company has not informed you and there is not a fix available right now. So that's how the landscape of the current security is. Now, okay, I want to take an example again over here. Let's say you are the ambulance driver and you are driving a patient to the hospital. Now, assume that you have a list of all the streets in the city, and or another option is you have a live map of GPS map, basically, which is telling you that okay, where you have to go, the connected view of the streets across the city. And say if there is a bridge that is broken, so if you have to reach the hospital faster, what would help you more? A connected graph, a live map, a GPS, which basically enables you, okay, if some bridge is broken, you can route via a different path. So right now what we see is millions and millions of vulnerability lists. So every year, like you can see, there are around 48,000 CVEs published in 2025. And there are millions of raw findings that your scanners actually produce. What we have just shown in the previous diagram with the connected graph, what you will see is you have 1,17,000 unique open source components that you need to act upon, and out of them, when you prioritize based on the context for what matters, you have only 2,600 packages which actually matters for you to prioritize and act upon. Next slide. Yeah, so before I talk about it, we move to the browser first. Yeah, the live attack. Recently, you all must have heard about the shadow attack that has happened. How it happened is quite interesting. The attackers gained access to one of the compromised token, NPM token, with the maintainer and the publisher status. What they did is they injected a worm in the package. What have access to the token that has access to that packages, and in turn they introduced the worm on all the dependent packages in that tree. So that's how the worm propagation happened, and the shadow attack surfaced. Can you click on simulate? That's pretty much how the blast radius of that attack looked like. Now, again, I want to ask all of you a question that at 2 a.m. in the night, you are sitting in an incident call for Shire. What's the best data that you feel will be important for you to look at? Like, you're a well-known team managing the operations for the attack that has happened. What's the most important data that you first want to have a look at? Anyone?
Starting of the attack.
Yeah, can you tell us what is that?
Where the attack started.
Yeah, where the attack started, and there's one more critical data that you want to look at is what is impacted. What across the enterprise is impacted. That's the data that most of the enterprises fail to answer, which is the blast radius. And with the CVE list, the blast radius is pretty much impossible to understand because the enterprise don't think in a list way, they think or they operate in a web, like a web, where your service connected to manifest to the packages and packages to vulnerabilities. So when you connect the CVEs into a single graph, you have this data sitting with you when you start the remediation campaign, or you want to design the campaigns for all the attack that has happened. You have understanding of what is impacted, what's the blast radius of that impact could be. Can you move the slide? Yeah. So with that data, this is pretty much what like the important metrics what the CISO would be interested in. What's the exposure, what the risk exposure for the enterprise. For the offensive security team, they would want to understand what are the top targets that we have in our enterprise. Now when you traverse the entire graph, you can pretty much understand what packages or the node connect to how many services and how many of them are vulnerable as well. So you get a data that is pretty much useful for the offensive security team to target, pen test, and they don't have to waste time, they understand what the real targets are. The vulnerability response team. So when they know the full blast radius, they can immediately start acting on it, and then they can immediately start rolling out programs, mitigation programs, which is the next basically how do we, and also the programs that we have for remediation are pretty much manual, and I think that's where one area where AI also comes in, which I'll be talking about in a moment, where you can auto-craft your remediation programs once you understand the blast radius and the impact of that. And next slide. Okay. Now this is a claim that AI gets smarter when it learns on a graph, and I'll defend it. I know this looks like a buzzword, but I'll defend this. That when you have a list, when you have a structured data that you train a model on, you get better results, you get better visibility into different signals that otherwise you will miss out. Because if you only have CVEs, the context for the CVE is pretty much the application or the individual impact, right? But when you have the graph across the enterprise, it tells you all the relationships across services to packages to vulnerabilities, and unlocks a lot of patterns for you when you train that over a period of time. For example, let's take a temporal graph, and we train the anomaly detection models on top of that. You uncover something that is not possible with the list of CVEs. And here I'm talking about a proactive defense. Now, previously we have seen like, okay, if you have an understanding of what's your blast radius, you can only mitigate, you can only try to mitigate once the attack has happened. But let's say something happens. Okay, let's take an example of executables. This is one of the briefs that has happened wherein an attacker spent 2 years pushing to the executables lib, and that attacker gained access to the lib as a co-maintainer, and after that he slipped the backdoor entry. So the executables basically shifts and all the lines distro. And this attack pattern was not identified by any security scanner. It was identified by a Microsoft engineer who realized that the application or the boot up time of the application has increased for some reason. It's just a half a second difference that made you realize something is wrong. This was a behavioral anomaly. This was a behavior that was not tracked by any security scanners. How we can train the AI better when you have a structured data? So you are maintaining the time series snapshots of what's happening, what's the relationship across your enterprise, and when something changes, when you see there are the privilege velocity, right? So if somebody is gaining an access faster, if you have that data point and you train it, you understand that, okay, this is a normal pattern. This has not happened in the past. There are other examples also, like Shahi Udul, who we talk about, right? So bomb propagation, you can also predict and proactively understand that, okay, if there is a anomalous pattern developing in the bomb propagation, right? You can verify with the car wall in your bit tag that if something is changed. Because when in Shahi Udul case, when the attackers, they did not do a git commit, they basically published it, right? They republished that bomb. So for you to understand, if you have those data and you have a structured graph, you can train it to understand if there is any anomalous pattern developing. So that's pretty much your proactive defense. Harsh, can you go to the browser? Simulation. The AI signals. Yep. So click on watch and give away from security. So this is basically, for example, how it would look like that you have routine publish, load dash, verified maintainer, you have XCOs, change documents is the commit, React DOM, by verified maintainer, but you see suddenly that the trusted maintainer publishes poor version in 19 seconds. That's your anomaly to look at. The pattern that you have never seen before. A new version adds an outbound network call absent from every prior release. So these are some of the anomalous patterns that you can detect when you train AI on a structured data set. And similarly, like for and right on the right, you see the GNN, which is a graph neural net. If it is trained on your temporal graph, and over a period of time, when it gains that the confidence increases, your detection will improve, and the detection will get better. We also have an attack example for type squat, which is where the name of package, for example, you're using Lodash in your library and somebody publishes a similar naming package, and if you are pulling that, it could bring the risk to the enterprise as well. So when you have a graph, you are understanding that, okay, I'm seeing a new pattern developing, I'm seeing a new package that is suddenly being used by a lot of services, which never existed before. And you can detect that anomaly and you can alert your teams to take action. That's proactive defense over here. Next slide. Yeah. So, okay, I think there's one more slide. Okay, go to the next slide. No, previous one, previous one. Yeah, so, okay. Now let's say, imagine you are an insurance agent and one of your customer takes a home near a river. How will you calculate the premium for the insurance if something goes wrong? Okay, I can help answer that question. Now, for that you'll have to understand that what is the likelihood of flood happening. Then you have to also understand if the flood happens, what will it impact? Like will it drown only your garage, or it will affect 2-3 homes, or it will just consume the entire neighborhood? And you also have to understand that what are the high value items that can be impacted. It is just the rug, it is the electronic items that will be impacted. So that's what will give you the insurance premium understanding, that what is the premium for that particular home that you've taken near the river. That right there is, the calculation is pretty much like you can see your blast radius, what is the impact, area of impact, your asset value, and your exploit likelihood. So what's the chance and likelihood of flood happening? So this, you can see over the number that you see, explanation for that is 1 in 100 day loss. Is basically, it's not a usual normal average day, it's a day where everything goes against you. So what would be the cost of that impact? The average value over here, this is the estimated or approx number, you can say 42 million if the attack happens on worst possible day and you do not have an understanding of a lot of these things as well. And there are some other keystone dependencies and metric, like you can see, like 23 packages predicted to receive a CVE with 90 days from code churn and material patterns. And there are other also stats for you to look at. Next slide. Okay. Now, yes. Then yes, pretty much if you click on different components like log quotient, it will tell you like the risk is quite higher because it might be available in the lot of PCI component, internet facing applications. If you click on any other like load dashboard, that example, the attack, one of the factors that we decide the insurance or premium on would be lower. That's why the cost of the impact would be lower. Now let's move to the slide. Harsh. So one more thing is from being is it present to is it reachable as well. Now let's say you have a fire alarm signals in your home, and it just goes on even if you start a toaster. That's a very bad signal to have, right? I mean, you have to act, or that alarm has to act only when there's a real danger. Similarly, let's say if you have the open source packages, but that open source packages is not invoked or executed for any of the call graph, then that means you can deprioritize the risk, and whatever is reachable, you can prioritize it higher for the higher impact. So this is one more data that if you add to your analysis and your graph, it produces results which can help you prioritize that. Okay, I have these vulnerabilities. And out of them, these are PCI compliant, internet facing, and on top of that also these are reachable. So this adds to that metric where you can enforce in a better way. Block what only matters. You are at an airport, the airport security authority, and what happens if they start searching everyone? Usually that they start strip searching everyone. That's a very bad signal, right? They only pick up based on if there's a risk that they detect. So, and that's what is happening right now as well. Now, if you just enforce everything, you lose the trust in the developers. The developers, they will understand whenever they get a patch or some kind of security communication, they feel like it might not be very important because we are throwing everything at them. But when you prioritize that risk better, you gain that trust and then you enforce things better. So, you have the top 10,000 raw findings this week, and out of them, how many vulnerable packages you have? What are reachable in the code? And an additional context about, like I said, PCI and internet facing. So you actually understand that, okay, with this structured data, you only have to block not 9 and deploy gate. Yeah, so this is also like I forgot to. So this is basically like you have all these packages, but it represents the same thing. Like if you click on severity signal only, that toggle, it tells you what is reachable, so you can try that better. Enforcement funnel. Can you click on this? Yeah. So what you will have in the vulnerability list, when you have a vulnerability list, you start pretty much with millions of findings. But what a graph can produce, you start like you have a funnel. So you have to map CVEs to packages to services, then you have to do all this prioritization funnel. When you have a structured graph, the output of the funnel is pre-computed and automated in a graph, where you can start your remediation campaigns and enforcement campaigns directly. Next slide. So, yeah. about that not everything is very important for us to prioritize. What are the crown jewels? When you understand that okay, a particular package is vulnerable and how many services it impact and whether that package is critical or not, you basically identify it. There can be additional factors on identifying the crown jewel as well. When you identify the crown jewels, what are the topmost targets that you need to start working on, start remediating and enforcing immediately, you basically can reduce the risk in a far better way. For example, CISO can also plan the campaign, the entire leadership can have the visibility of what are the topmost items that we have, and if we fix those, how much of risk reduction that will bring to the enterprise. Next slide. Okay, so we spoke about the insurance premium, we spoke about the different threat landscape, and when you are better prepared to tackle the issues proactively and reactively, then you can pretty much bring down the cost of any of the attack that develops or that happens. When you understand your attack surface better and you can proactively defend it with the patterns developing in your code. So with this AI accelerated development, the organizations that will survive will not be the ones who have a lot of scanners, will be the ones who have a lot of context, and that's the shift, ladies and gentlemen. CVEs to the context, that is pretty much important. That's all from my side. Any questions?
Two questions we can take up.
Sir, this side, my name is Jashin. Sir, actually you just said that shipping the entire code from directly from AI would be adding multiple vulnerabilities to the product, right? But like in Google I/O only, like the Google the CEO, Mr. Sundar Pichai himself told that 70 to 80% code is in Google itself been generated by AI only. So I just wanted to ask, like, are they not aware of vulnerabilities, or like how they are tackling that? Because
to answer that question, first of all, you said 70 to 80%. I would say 100% of the code right now is being generated by AI itself. So humans are not writing code anymore. If they're writing this, that's anomaly. The thing is, when you, like I said, like it's not about they're not detecting. The problem is what we identify, what we said. No scanner can detect a lot of CVEs because that's not published yet. A lot of these published disclosure happens quite later, right? So when you are writing the code, something might be higher, but that becomes critical in coming days, right? So, and whatever you are understanding, do you all need to prioritize that too? So we have to understand that gap as well. So, like you said, 70-80% development happening, but do they